Welcome back to Taproot TV. There are so many things that are getting automated these days. I mean, from cars to when you want to start your coffee in the morning to
Ooh, I
your
didn't think of that one.
airplane. Yeah, your airplanes, your
Refrigerators, your
refrigerators.
air conditioning.
There are so many things. And yeah, that's even getting more so. All the things in your house that are automated
Yep.
now while you're not even there. So, one of the things,
Making decisions for you. Artificial
oh dear.
intelligence. I monitor you and decide you would like the air conditioning like this.
Well, if they're learning, like I was talking to Alex the other day, if they're learning from what you do and your actions, then that would come
It
into
might
play.
work. It might work.
Well, that's what we're going to talk about today: automation and human error. And so, is one make errors fewer, or do we end up with more errors?
Well, that's the whole point of it, isn't
Yeah.
it? The goal of automation is to reduce that human error that we all think of as, oh, that's bad. People are so unreliable, and we can make machines that are more reliable, right? That's what we hope.
That's the plan.
And so you get one of these major accidents, though. We were talking before we started this about the 737 Max accident, where the solution that they implemented so they wouldn't have to train those pilots more.
Right.
So we didn't want to do that because that would require recertifying the pilots, which requires simulator timing. So we'll just add this automation in that'll make it fly, take care of that human error, pulling back on the stick too much, climbing too fast, and the plane will take care of it.
Right.
And that didn't work out
Did
so
not
well.
work out so well.
And in that case, they had a critical system, flying of the plane, and by their own standards was supposed to have double redundancy, and it had only single point failure, which isn't a very good
No.
automation feature. If one sensor fails, the automation can do things you don't want it to do, and then you don't train the pilots on it at all. You don't
You
train
might
them what
need
to
to
do.
know how to override something and correct something when it's
Well,
going
the
wrong.
amazing part, I don't know if people have dug much into this accident or not, but the day before, the same plane, the Indonesian airplane that crashed, had the same problem the day before. There was a third pilot deadheading it with the other two pilots who were flying. As they were diving down, he said, oh, what's it called? It's trim tabs is what you're doing, but there's a switch. You flick a switch.
Yeah.
And he yelled out, flick the switch, flick the switch. And they flicked it. And even though they did, they were in such a steep dive,
Yeah.
they had a hard time. Both pilots pulled back
Oh my
as hard as they
gosh.
could, barely pulled out. Now, they flew with that system disabled
Yeah.
because when you flip these switches, it disabled the system. All you've got is a manual trim tab
Right.
then. And
So this guy knew this.
so he knew it. They reported they'd had a problem. Maintenance couldn't repeat the problem because the only time you have the
Right.
problem is when the flaps are all the way up when you're in this point in flight,
Yeah.
and they were on the ground, so they didn't have that problem. And so then the next day, the same thing happened, and the plane crashed. Strangely enough, the Ethiopian Air flight that crashed had the same problem, obviously. And the co-pilot, who didn't have hardly any experience at all, just decided to flip those switches. He did. They recovered, but it wasn't still flying right, they didn't
Right.
think. So he put the switches back, and they went into another dive and died. So they actually had solved the problem they didn't
Right.
know they
didn't
had.
know they'd done
And
it.
he put it back because he wasn't sure, and it crashed.
Wow.
So it's one of those things. Automation can be a savior, or
Yes.
it can be something that contributes to an accident. Let's put it
Sure.
that way.
Well, a lot of the things that people relate to these days are the cars. And the thing that they can relate to the most, I think, is that those sensors, they do think quicker than the human mind can think. And they can reassess the situation usually a lot quicker than a human mind can think. But what if something goes wrong with that sensor?
So this is you've got sensors
Yes.
that a machine can react faster than a human.
Yes.
But the point of driving usually is that you leave yourself a margin so that you don't have to react that
Right.
fast, which is why you don't tailgate or whatever.
Right.
Now, in theory, when when everybody's car is fully automated, they'll be able to link up in in a train and go much faster with much smaller following distances, and that should reduce traffic accidents and stop traffic jams.
Yes.
Because instead of everybody jockeying around for lanes, the automation will do that automatically, and you'll be able to flow more traffic quicker.
Yes.
Now, in theory.
In theory. Right.
So there could be some good things come from automation.
Because you're assuming somebody's not going to change their mind.
Well,
on where
you're
they want to
assuming
be.
somebody isn't going to come in with a 1958 pickup
Yeah,
truck in the
right?
middle, and he's not playing the game
He's
at all.
not playing correctly at all.
Yeah.
He's ruining the whole thing.
Yep.
Well, it's like, Ken Reed, his truck that he has, he's supposed to be able to go four-wheeling with it and all that kind of stuff. And then he used that cruise control a lot on his car. Well, he noticed it was not slowing down. Well, it turns out one of his sensors had some dirt on it.
A dirty
And they're
sensor.
like, did you go four-wheeling? And he's like, it's a Raptor. Yes, I went four-wheeling. And that was, so it's little things like that.
You just have to know to clean off all your sensors when
Clean
you're
your
done.
sensors. But that awareness, that's where the person has to come in.
So that a lot of times they call this function allocation. Well, human factors types call it
Yes.
function allocation. And there's jobs you're going to give to the human and jobs you're going to give to the
Yes.
machine. And so because this machine might be quicker and more reliable on monitoring, you might decide, well, the machine's going to drive the car and Ken's going to do the cleaning.
Right.
His
He's going to
task will be
clean.
cleaning.
And he's going to keep his eyes on the road.
Well, now that's the thing.
Yes.
That's the thing that may not be a very good job for humans.
Yes.
Being a redundant system, having to sit there and watch and be alert in case you need to take over. Because
Right.
remember, the machine's supposed to operate much faster than you are, so they're not going to give you much time
No.
to take over when things go wrong. And if there's an alert noise or something, maybe sort of like you wake up and decide, oh, what am I supposed to be doing?
Right.
And that may not be a successful backup to automation.
No, and I know they build those things into the cars and stuff. Like if your hands aren't on the steering wheel for a certain period of time, it'll do that alarm or things like that. But people are very creative, and they have ways
I don't know how they did it, but of
things.
course, I know in the course we do, the Stop a Human Error
Yeah.
course, we've got a video of this guy driving along completely asleep, and these people are going along beside him, videotaping
Yes.
him, and he is just completely
Yeah.
out of it. And you're not supposed to be able to do that,
No.
right? But it happens, and they've had accidents where. I remember the one was an NTSB investigation. We'll put a link to that on there.
Okay.
It's one of the Monday accident articles we did. And they were in the left lane, which was a, what do they call those lanes? The HOV lanes.
Yes.
And electric vehicles could use the HOV lane even if there was only one person in the car. So they were in the left lane, and there was an exit ramp to the left. And so the line went away on the left, and the car centered itself between the two lines. And then there was one of these crash barriers.
Yeah.
And the crash barrier had been damaged by a previous crash, so it was already all the way collapsed. And this car ran into basically concrete
Right.
straight on. And, 3 or 4 other, it flew out into the other lanes, and about 3 other
Wow.
cars collided trying to avoid that accident. And I would assume the person, because they didn't survive,
Right.
I would assume the person driving wasn't watching.
Wasn't watching.
And just didn't notice that it was bearing off to the left and didn't take over. And the
that's-
car didn't realize it until it was too late that there was a crash barrier there.
A lot of what we teach has to do with the fact that we know humans are going to error. And these systems, it's almost like their backup is that the human is not going to error and the human is going to be alert.
Exactly.
And so it sounds like some room for some new safeguards.
So a guy named Jens Rasmussen was an amazingly smart guy,
Yeah.
worked for the Halden project over in Norway, which was working on advanced reactor designs. And I was working on function allocation at the University of Illinois. And We got together at a professional society meeting, had lunch together, and he drew this diagram. It was a copy of the goodness of design, or the variables along this thing,
Yes.
and how good the design was up here.
Right.
And he said with old analog designs, that was a pretty flat curve.
Yeah.
It was if you missed the optimum design by a little bit, the human was good enough to be
Right.
variable enough that it didn't degrade performance all that much. It did degrade performance, but it was a flat curve. The other curve, though, with automation, you either got it dead right, and it was like 10 to 100 times better than the human. But if you got off a little bit and your automation wasn't quite the right design, all of a sudden you were way worse than the manual system was.
Yeah.
And so you'd say, well, automation, it makes it easier for the human. It may make it easier for the human who's sitting behind the wheel.
Right.
But it may make it much harder for the designer, because they have to be right. Because if they're wrong, bad things happen.
Well, and very often we talk about the designer and the engineer of these types of things aren't necessarily the users a lot of times.
Even if they are, they're thinking like engineers, right?
They're thinking.
I mean,
they're
I've got a
not
master's
thinking
degree in
like,
engineering, and that doesn't mean I think like everybody else does.
Oh.
So that's one of the big lessons from human factors, is that you have to get the user in design, early on in the design, to not just design it so the engineer thinks it's
Yeah.
right, but to have a number of people try it out, test it, and see what works and what doesn't.
Yeah.
Because all of a sudden you're going to find out, the way I think, no matter who you are, I'm not blaming engineers for this. If anybody thinks their way is the only way,
Right.
they're going to find out that when they get a multitude of users, there's lots of other ways to think about this.
Right. And people's, because everybody's brain functions differently too. So you have to keep a lot of that stuff into play, because so you're dealing with humans failing and machines failing.
So you've got two different
Yes.
systems, and you're bringing them together, and you're trying to optimize that merging of the two systems. And that's why it's harder to get that perfect design.
Right.
And if you fail, it fails catastrophically a lot of times.
Well, and most people in life realize a lot of times the more electronic things get, the more things that can go wrong. So, I mean, I feel like there's just still a ways to go before full automation really.
Well, wait. So one of the things you would say, well,
Or maybe I'm
but
just
if we
nervous.
but if we wait, it's the experience. How do you learn? You learn from experience. What happens that makes you learn? You have bad experience,
bad
right?
experiences.
And so there's going to be accidents that they learn from. I mean, we shouldn't have had to learn from the 737 MAX. They were violating one of their own rules, right?
Yeah.
They didn't have a redundant system, unless you consider the pilot inventing things on the fly as
Well, and they had like 5 seconds in between every time they could kind of recover a little bit, and then the.
Well, did you know that was actually designed to be a much less intrusive system, and somebody decided to crank up those variables and make it put the nose down more and give the humans less time? Isn't that amazing?
It's
Somebody
very
actually
amazing.
made that
That's
decision.
a really
and so
good word
they
for it.
used to have, I can't remember, it was something like a really slow rate
Yeah.
of the trim changing, and they made it like, and I think it was times 10 or whatever.
Yeah.
It changed the rate that much faster because they wanted to intercede.
Right.
And once again, nobody thought they were doing something
Right.
bad.
No.
They thought they were making it good.
Yes.
And they thought they were making it better for the pilots, but it wasn't.
But it wasn't. Yeah.
And the other interesting thing I was reading about the other day was the testing that was done on this was all with test pilots. And test pilots, I don't want to say they never make mistakes, but they are really, really experienced pilots. So they tended not to over pull up too hard. They tended to know more about the plane. They tended not to, and I'm sure they had a test where they tested the system, and sure enough, it did put the nose down. But the pilot didn't overreact and pull back too hard again, so they didn't get into one of these cycles where the plane just kept getting steeper and steeper and steeper descents.
Kind of reminds me of how, like, when you're a young driver and a lot of accidents happen because you overcorrect.
Well, and that's a good example, because when you're very new, you probably don't push it that hard.
Right.
But you get to a certain point where you think you know
Yeah.
what you're doing, and that's when you're probably the most dangerous, before you do gain a whole lot of experience. And of course, a lot of people never gain experience at handling cars at limits and that kind of thing. So they a lot of times can overcorrect
Right.
and cause accidents by overcorrecting, get your car to fishtail or whatever, and not know how to get out of that.
Now that's where some automation has come in and been helpful.
And there has been,
Yes.
right?
Because your car will correct for you.
Unless it goes crazy.
That's crazy. Which,
Which we were talking about. We were talking about the what was it called? The guy at the summit who talked to us from the
Abagnale.
Frank Abagnale,
Yes.
who was the Catch Me If You Can
Yes.
guy. And he was talking about the FBI, and he was talking about, well, if the FBI, if you got a new modern car, if the FBI can get within, I think it's 35 feet of it, they can shut the car down.
yeah.
And he said it'll only be a year or two until they'll be able to take control of your car from Washington, D.C. And you think, well, if the FBI can do that, how do I know somebody else can't?
hackers.
Or some hacker, or interference could cause me to have something weird happen.
Well, we think some of the systems that are in place out there, some of the most secure computer systems in the world get hacked.
Yeah.
I mean, I don't know that any system so far has proved itself unhackable.
Don't know the answer to that. I'm not in the NSA.
So I
don't know
don't like the
answer to
idea
that.
of them hacking my car.
So there you go. So this is all the features of automation, and where this all leads is
Yeah.
most people haven't even thought about this. They haven't thought about the 737 MAX type automation. They buy automated systems. They're buying systems that have AI features and installing them in their plants, installing them in their fleet. I bet there's trucking companies out there that are thinking about buying automated trucks. And how are they going to evaluate those before they put them into production?
Yeah.
Not how is the manufacturer going to automate, but how is the purchaser going to decide, is that the right level of automation for me? Is that automation reliable? What kind of testing have they done? What functions have they given Ken? The function of cleaning,
cleaning
the
the
sensors,
sensor.
which he didn't know about.
Right.
And which things are they giving
Yeah.
to automation? And is that the right function allocation? And we talk about that a little bit in the Stopping Human Error course.
Yeah, and about the Ken thing, we're hoping that people follow the rules when automation does become more mainstream in a lot of things, but people have to play their role. You can't just close your eyes and go to sleep. You just can't get your book out and read it.
Well,
And
I was looking at Alex's car,
Yeah.
and it's got little cameras all over it. You're talking about
Yes,
Ken has
I-
one, and now you're thinking about it, thinking, well, what happens when it rains?
yeah,
Those cameras are going to start getting an unclear picture. How do they work as well in the rain? What
Right.
if it's a really hard rain? What if it's a foggy day? What if you'd really like it when your senses are the worst in really thick fog for its senses to be the best? But is it? I have no idea. That's another good question,
well, and
isn't
then
it?
what happens to the human skill when suddenly you're taken off the job?
Well, okay, so we don't think about that too much now,
Yeah.
because most of us have had lots of experience driving. So if you get a car that does it for you, you think, oh, I'll be able to. It's
Right.
like once you learn to ride a bicycle, you can always ride a bicycle, right? But what if you never really got much?
Right.
What if you went through driver's ed with an automated
Yeah.
car and you barely learned to drive, and now you're driving, and all of a sudden in an emergency situation it says take over.
Yeah,
Whoa.
that's scary.
That could be hard.
Right. Yeah. There's a whole lot to this. It's such a deep topic, and I love our new course that we have. You taught it at the summit, the How to Stop Human Error course, or Stopping Human Error course. It's based on so much of this.
Yes.
So tell us a little bit about what people can take away from that.
Our purpose is for this course to give you knowledge and practice at some of these techniques that can help people not make as many errors, so that you can go from poor human performance, which probably the worst would be an inexperienced driver
Sure.
taking over control of a car in an emergency situation.
And not having that
In which,
muscle memory or
in which
reactive
case
skills.
your odds would probably
Yeah.
be less than 50-50 that would be successful.
Right.
To getting that performance to be only one mistake out of 10,000 times. And that's a huge advancement in human performance. Then, if you can get it to 1 in 10,000 and you put several redundant safeguards in place so that each one of those has 1 in 10,000 chances of failing, then maybe you've got a system that basically you're never going to fail. It's more than 1 in a million chance that it's ever going to fail, and you as an individual operator are never going to see a failure occur.
Yeah.
And that's what you want.
That is what you want.
That's what you want. You want to have in these critical systems, there's never a failure. So what we do is we teach them techniques to improve human performance, to improve that error rate, to make it hopefully get up to 1 in 10,000 times, and teach them all these different techniques, and then they can choose which ones I'm going to implement at my facility to try to improve human performance and actually test and see what works.
I love how you go through all those different human performance techniques and you do some pros and cons about them. So people walk away very educated on.
And they all have a pro, and some of them have many, and they all have at least one con, and some of them have many. And some of them you will hopefully leave the course going, gosh, those are good things I'm going to try. And other ones you're going to say, you know, a lot of people are pushing this, but this isn't a really good idea. There's human factors research that says this will not work well.
Yeah, it's such an interesting course. We're having it in Knoxville, Tennessee.
Yes.
September 15th and 16th.
Yes,
Look at
it
us,
is.
we knew dates this time.
That's it.
Our human performance is improving.
Yes, it is.
But no, it's a fantastic
I think
course.
there was a 1 in 10,000 chance that we both knew that.
Well, we weren't good at dates last week, but we got it this week.
Yes.
We learned from our mistakes. But I took that course at the summit, and it was fantastic. I think there's so many different things people can get out of it. And we are going to have it here in Knoxville, Tennessee. You and Alex are going to be teaching it.
Yep.
And if you haven't been to Knoxville, September is a lovely time to be here. And we're going to have a lot of information about the course, how to sign up, register, all that stuff on our website. And we'll also have links to it in our descriptions and everything, so it's easy to get to.
The other
You can
thing we
snip my
should tell
hair.
them is what?
Oh, you
They
want
need to
subscribe.
click the button.
Yes, subscribe and hit the
Wherever that button is.
notification bell so that you get all of our videos, notifications of when we put them out, because we put them out every single week. There's a lot of really good stuff out there.
They could keep busy for weeks just watching the ones they've missed.
People want some online learning. There is over 150 videos on our YouTube
I didn't realize there was
page.
that many.
Yes, on our.
Ben has been busy.
Oh boy. But they're great. The topics are great, and they're short and to the point, and like, usually 15 to 20 minutes, and you can sit in there and you can learn about all kinds of stuff. So we want you to go to our website, our YouTube page, and subscribe and hit the notification bell. You'll see these on our Facebook page, and also if you will get subscribed to our newsletter. If you haven't already, go to taproot.com and go subscribe there. That's how you're going to find out about everything. You're going to get all the great blog articles. There's so many things there that you can take home and
Every
make your
week
program
there's
so much
at
better.
least 2 or 3 good articles that will teach you
Yes.
something besides the ones that say, hey, here's the upcoming courses.
And they're free.
Yes.
They are free. Some valuable years and years and years of experience are built into those articles. So, well, Mark, thank you.
Thank you, Ben.
I appreciate it. I always love this topic. It's so fun and it's scary. The future is scary.
If you can't tell, Benna gets worked up about automation.
I'm getting an old truck. Anyway, we appreciate you for being here, and we hope to see you back here next week. Thank you.
Okay, bye.